Absolute value equations. Let's say first that the absolute value of a real number x, and we're going to say that it's written. Here's your absolute value symbol. You read that as the absolute value of x. And what it means is the absolute value of a real number x, written absolute value of x, is the distance the number is from 0 on the number line. That's why it's always positive. That's why absolute value is always positive, because distance is always positive. Alright? Distance is always positive. So look, what's the absolute value of 5 equal to? It's equal to 5, right? Because on the number line, you got 0 and you got 5, and the distance from 0 to 5 is 5. Well, what's the absolute value of negative 5? How far is negative 5 from 0 on the number line? That's also 5 units. Okay? So, the absolute value of a 5 is equal to 5, and the absolute value of a negative 5 is equal to a 5. And because of that, because the absolute value of two different numbers is equal to the same number, is kind of the explanation of why you have to solve absolute value equations the way you have to solve them. And here's what I mean. When you're solving absolute value equations, and let's say you need to solve, get off there. Let's say you need to solve something like the absolute value of 2x minus 1 is equal to 5. The way that you solve an absolute value equation, now there's a couple of key things that need to happen. Number one, before you go into the real solving part or the rewriting of the equation, on the left hand side of this equal sign, do you see how the only thing over on this left hand side is the absolute value symbol and what's inside of it? Okay? When you have just the absolute value symbol on the left hand side, you rewrite the equation twice. And you say 2x minus 1 is equal to 5, and you say 2x minus 1 is equal to negative 5. And you solve both of those equations. Alright, so we add 1 to each side. So 2x equals 6 and divide by 2. And then we add 1 to each side. So our 2x is equal to negative 5 plus 1, negative 4, and divide by 2. So there's two solutions for this absolute value equation. X can be equal to 3, or x can be equal to negative 2. Then, what you're technically supposed to do is you're supposed to check both of the solutions. Alright? That means substitute them and see if they work. Because you're going to be getting to a point here real soon where you're going to get like two solutions for a problem, but only one of them will work. The other one won't work. So we just got to check them. And these are, we can take the absolute value of 2 times 3 minus 1. Does that equal 5? Well, what's 2 times 3? Well, minus 1. And the absolute value of 5 equals 5, so that one works.
Teachers, please release students with the last initial M through R to the gymnasium for pictures if they have not had their picture taken. Again, M through R. Thank you.
Okay, we don't check it in this equation. We check them in the original equation. Because an absolute value is never going to be equal to a negative, so we don't do that. So then over here on this second solution, we got the absolute value of 2 times negative 2. It's negative 4 minus 1 is negative 5. And the absolute value of negative 5 is equal to 5, so that solution works. So both solutions work. They're both good solutions. Everybody good with that? Okay? It's a fairly straightforward absolute value problem. Absolute value is by itself on one side and it's equal to a number. So rewrite the equation twice. Equal to the positive and equal to the negative, and then just solve it twice. Okay, so now the progression is to problems that require a few more steps. So now we got 3 times the absolute value of x plus 2 equal to 8. No, don't write that all the way yet. I forgot there's another couple numbers in here. That's minus 1 equal to 8. Now, do you see how these don't look the same, do they? This one that I just wrote don't look like this one, does it? There's more over here on the left side. So before we can write our two equations, we got to make it look like this. Clear? Just the absolute value on the left-hand side. So we got to do a little manipulation. It's like when your gravy's too thick. You got to do some manipulation, right? What do you do when your gravy gets too thick? You add a little more liquid, right? Whew. What do you do when your gravy too thin? You add a little more flour or cornstarch to it. Now, what you got to be careful of when you're manipulating that gravy, you get your gravy made, right? And you're working on it, and you're just about finished with it, and you're like, man, it's too thin. It won't get any thicker. You can't just take flour and drop it in there. No. You'll ruin your gravy. What you do is you take a little bit of flour, you put it in a little bowl, and you put a little bit of butter in there, or you put a little bit of whatever your liquid was in your gravy, whether it's broth, vegetable broth, beef broth, whether it's milk, whatever you're using as your broth. You put those two together in a little bowl, you stick it in the microwave for about 20 seconds or 30 seconds, right? You get them warmed up, or you could even put butter and flour together. That works the best. Butter, flour in the microwave, 20, 30 seconds. Whisk it real good so it's broken down. Then you add that. That's called a slurry. You add the slurry to your gravy and you stir it in, and that'll thicken your gravy up for you. If you just drop the flour right into the gravy, it'll clump, and you won't be able to get them clumps out, and you'll look like an amateur chef. So don't let that happen to you. Don't let that happen. So back to manipulating. If you're manipulating this equation, we're gonna add 1 to each side right here. So now we got 3 times the absolute value of x plus 2. It's equal to 9. And we got it closer to looking like what it's supposed to look like, right? But it's not all the way there yet, is it? Yeah, so that 3 next to the absolute value symbol is just like 3 next to parentheses. If we divide both sides by 3, these 3's will cancel. The absolute value of x plus 2 is equal to 3. So now it looks the way it's supposed to look, right? Okay. So we're going to rewrite this. We take x plus 2, we make it equal to 3. We take x plus 2, we make it equal to negative 3. So one of our solutions is x equals 1. Another solution is x equals negative 5. And then you got to check both. Check both. Back up here. Alright, if x is 1, what's 1 plus 2? It's the absolute value of 3. Times 3 is, minus 1 is. Okay, so that one works. In here, negative 5 plus 2. Negative 3. Absolute value of negative 3. Times 3. 3 times 3 is 9. Minus 1 is 8. So that one works. They both work. Got it? Who you texting? You Snapchatting? Or texting? Are ya? What's mom doing? Aw, so she's bored? You're bored? Oh, say that one more time. Okay. Got it. Ask her what she's cooking for dinner, and then you'll decide. Say if you're making meatloaf, mashed potatoes, green beans, I'll consider it. With gravy. Gotta have gravy. Gotta have gravy.
So, I know it's the absolute value of 3 times 3, but what if it was negative 3?
You can't. You're not going to get a negative in here. Whatever comes out of these symbols
No matter what it's positive.
is never going to be a negative. Okay? So you can have a negative in there, but then when you find the absolute value of it, it turns it into a positive. Okay? Alright, so I keep looking at that clock and it's still like 12 minutes till 4. Alright, so let me give you a couple of these to do for practice, and then we'll come back and we'll talk about something else. Got it? It's not 8, is it? September already. Alright, so let's just do a couple of these for practice, please. We got a 2 times the absolute value of 3x minus 2 equals 14. Let's see something here. Let's look at this for a second before we move on. Let's see. I got some room maybe over here. Look, what if you get this? What if that's the problem that you're given and you're asked to solve for x? Say again? What's on the left-hand side? Absolute value symbol? Doesn't this say that the absolute value of, it's 3x plus 3, but doesn't it really, it's just something, right? Can the absolute value of something be equal to a negative? Can't, right? Because remember, absolute value is always positive. Because you can't be a negative 4 units from 0 on the number line. Negative distances don't exist. Right? If you walk from the distance from me to the door might be 22 feet, but the distance from the door to me is not negative 22 feet, is it? Still 22 feet. It's still distance. If you get in your car, you put it in reverse, and you drive to Gainesville, you're still going to drive 180 miles. If you put it in forward and drive to Gainesville, you're still going to drive 180 miles. You can't go negative distance. There's no such thing as going back in time in distance. That's why your odometer don't ever go backwards, does it? It just keeps adding. You used to be able to get him to go backwards. My dad knew how.
Really?
Yeah. Yeah, he did that more times than he should have. And then, and then he got, well, he's not alive, so they can't convict him of anything at this time, but he would take the old odometers where they clicked, not digital. There was dials and the number. Man, he would get these cars real cheap because they had way too many miles on them. And then he had this thing set up on his workbench in his garage, and it's called a Speedo Cable. It was a speedometer cable that went from the back of your speedometer and it went all the way down to your transmission. Well, as your transmission rotated, as the drive shaft went in, you got your universal joint, it rotated the wheel. As that motion occurred, it spun your speedometer. And that told the wheel how fast to tell you were going, and it also made the clicker click. Okay? So he came up with this mechanism that took the back of a Speedo cable and connected it to a power drill. Alright? And he had it all set up. And then he would plug the drill in, and he would put a zip tie on the trigger, and that drill would just run on the workbench for like days. You'd turn the whole thing over because they would stop at 100,000. So you buy a car, say it's got 98,000 miles on it. It's worth not much. Well, if that same car has 29,000 miles on it, it's worth a lot of money. So once that odometer would get to 100 grand, everything would just go back to zero. And then he'd go out there and check it tomorrow. I need about another day and a half. And when you did it with the drill, everything would align perfectly. When you did it without the drill, if you turned it back by hand, it would be like 2, 9, 3, 1 point, 2. And somebody would look at it and go, man, you turned back the odometer. No, I don't know why none of the numbers were lined up. The only reason the numbers wouldn't line up is because somebody turned it back. But if you hooked it up to the drill and you let they would flip them over perfect. So he did that. Yeah, he did that all the time. Okay, so yeah, not legal, but
Oh,
if you've got something in absolute value symbols equal to a negative, that's no solution. There's nothing I can fill in here for x to make an absolute value equal to a negative. Okay? So when you see it, that's where you can stop. But look, be careful there's not like a negative 2. If you were in this case, well, before you can say no solution, you got to divide both sides by negative 2, right? So your absolute value of 3x plus 3 is now equal to a positive 2. Now you can finish it. All right, so don't jump on the no solution wagon too early. Got it? All right, good. Where am I here? Let's see.
Teachers, at this time, please check with your students. Anyone with the last name S through Z, please send them to the gymnasium for their picture. They have not had it taken already. Thank you.
All right, just go ahead and do those 4. They're pretty straightforward. Then we'll go over them and move on.